Hey guys, Caden here. I just wanted to do a quick video today talking about the new Majorana 1. Yes, not the marijuana one, but just as interesting, if not more, the Majorana 1. Okay, so what is the Majorana 1? Well, it is the new quantum chip from Microsoft. Now, before I get into any of this and my thoughts on it, as a person with a physics degree, as a person who works in tech for many years at this point, what is my thoughts on all this? We'll get to that in just a moment. What I want to do first is just briefly show a clip that Microsoft released about this. So here we go.
Introducing a breakthrough in quantum computing, the Majorana 1. A new approach that ignores the limitations of current models to combine the power of millions of potential qubits all working together to solve unsolvable challenges in creating new medicines, entirely new materials, and helping our natural world. All on a single chip. The Majorana 1.
Alrighty guys, so there you have it, the Majorana 1 release video from Microsoft. It's short, sweet, it looks nice. It doesn't really contain a whole lot of information though. There is other videos they have posted explaining more in depth, of course, and there's many articles posted online about this at this point. So I will link to that all down in the description if you want to go check that out for yourself, and I recommend that you do. But what is this? So what is this stuff? And how is it different from already existing quantum computing chips? And what can we get out of this, right? So how does this relate to everyday people? Okay, so first and foremost, it's a quantum computing chip, and what that means is that classical computer chips use zeros and ones to interpret information. Every piece of information is called a bit. It's either a 0 or 1, and using that, everything in computing is made. Okay, so quantum is different by allowing bits to be either a 0 or 1, being a probability of either, allowing to see more possibilities with the same information. And it's really difficult to do this, and there's a lot of problems that come out of this, and some of that is called interference. Quantum interference is when you're trying to interpret this stuff, and outside forces like electricity, magnetism, all these things can affect this quantum information, and it can actually revert it back to just being a normal bit and not having any of that special quantum ability. This already exists, of course. It hasn't been super large scale, and we haven't really done a whole lot with it, I wouldn't say. But the Majorana 1 could change that, and that's because the Majorana 1 uses a new state of matter, a fifth state of matter, as Microsoft claims. Well, this new state of matter is called the topoconductor, and what a topoconductor is a superconductor, which is a material with no electrical resistance, but it works with the Majorana particles. Now, long story short, in quantum mechanics, the Majorana particle is a antiparticle and a particle in one, meaning, long story short, when you use this for quantum computing, it presents little to no errors or quantum interference, allowing for a lot more stabilization in the computing space. And so this claim of a fifth state of matter is kind of where my opinion may stray a little bit from what they're printing in the papers here, and maybe there's people out there in the community, or maybe you yourself, if you're interested, maybe agree with this, but since the quasi-particle and quantum mechanics that they're using isn't necessarily a technical, like classical new state of matter sense of the word, maybe we call it something else. Maybe it's not a fifth state of matter. Maybe it's the first state of something else, right? Not matter, right? Because quantum stuff, it's murky, it's gray area, it's hard to explain, it's hard to understand. It's taken forever to even get evidence for the stuff theorized almost 100 years ago at this point, right? This stuff is difficult. So I don't know if just lumping that into all the other classical states of matter makes sense. Maybe you agree, maybe you don't. I don't know if that's necessarily the important thing here is, but I wanted you guys to know what was going on, and most importantly, finally, the conclusion that you've been waiting for. What does this mean? Just like computing changed the world already, quantum computing will change the world again. And I don't say that lightly. I mean that. I mean that from a physics point of view. I mean that from a software development point of view. When we get quantum computing to a level that our standard computing is at right now, meaning that we can do these operations with as many bits as we want, essentially, without large errors getting in the way, then we will be able to solve a lot of problems that we're facing right now in medicine, in infrastructure, pretty much all aspects of life, I would say. And that's all if they continue to progress on this idea and this technology like they hope to, right? So it's not quite there yet, but it's on its way. It's a good first step. So I'm really hoping that they do succeed. I'm really hoping that it's not just a bunch of hype, and they don't really, get much further than this. I'm really hoping that it does come forth and change everything for all of us, right? Who doesn't want a better, more advanced world? Everybody does, I would say. So yeah, I just wanted to ramble to you guys. I hope you guys enjoyed that. Please let me know if you wanted to hear any more about any of this quantum stuff, computing stuff, just rambling. Just let me know. So yeah, until next time, guys. Peace.